All forms of energy can be one of two states. It's either going to be potential or it's going to be kinetic. Kinetic energy is energy of motion. It's energy in action. There's movement. There's stuff going on. You can see movement. Like when a person runs. If you skateboard down a hill, that's kinetic energy. The faster an object moves, the more kinetic energy it's going to have. And the greater the mass of a moving object, the more kinetic energy it's going to have. So with kinetic energy, it's going to depend on mass and velocity. The more of mass and velocity it has, the more kinetic energy it's going to have. Potential energy. It's stored energy, energy at rest. So there's not movement going on like with kinetic energy. It's stored chemically in fuel or gasoline. It's stored in the nucleus of an atom or in the food you eat. Or it could be stored because there's been work already done on it. Like when you stretch a rubber band, that's elastic energy. When you wind a watch, when you pull back on a bow's arrow, it's ready to spring forward. It has the potential to do something else. Or when you lift the brick high up in the air, it has a potential always changing form. The most common way it does this is by changing from potential to kinetic or kinetic back to potential.
In a hydroelectric power plant, electricity is produced from water. A dam is built across a large river to hold back the river water and raise its level to form a reservoir. At the bottom of the dam, there is a floodgate. Water flows through the penstock and rotates the turbine. The flowing water rotates the turbine, which is placed at the end of the penstock. The turbine, in turn, rotates the shaft that is connected to the coils of a generator. These coils are placed in between strong magnetic poles. The rotating shaft turns the coil.
Atoms are the building blocks of the universe. The center of an atom is its nucleus, made up of protons, neutrons, and electrons. Protons are positive and electrons are negative. Opposite charges attract each other, and like charges repel each other. Electricity is produced when the negatively charged atoms move. Most objects' atoms are arranged randomly and evenly. Magnets are different. They have particles arranged accordingly in each end, north and south. Domains are formed this way to create a magnetic field around the magnet. A magnetic field is an imbalance in the forces between the ends of a magnet. A magnetic field can be used to produce electricity. Every time there is a change in a magnetic field, an electric field is produced. Every time there is a change in an electric field, a magnetic field is produced. Electricity travels in closed loops called circuits. The pressure that pushes electrons in a circuit is called voltage. It is a measure of the strength of the current in a circuit and is measured in volts. Electrical current is the number of electrons flowing past a fixed point in a given amount of time. Resistance is a property that slows the current or flow of electrons. Resistance is measured in ohms. Ohm's law states that in many materials, especially metals, the current that flows through a material is proportional to the voltage. The formula is voltage equals current times resistance. Electrical power is the rate that electricity is converted to another form of energy. The formula for electrical power is power equals current times voltage.
This is an introduction to the importance of electromagnetic induction. Here's a brief example, but with a wire instead. If we were to take a wire which has a magnetic field going into the plane, which can be seen by the small crosshairs, and we were to physically move that wire downwards, then a current will flow to such as to oppose that force. In other words, a current will flow that will tend to cause the wire to go in the other direction to oppose the force that's causing the current in the first place. Which means if you use the left-hand rule, you've got the force going upwards, the resistive force, and the field going inwards, which will mean the current will flow to the right, as you can see. But suppose it didn't work like that. Well, we'd have an infinite motion, a phenomena which just isn't possible. Why, you say? Let's say the current moves to the left, reinforcing the force instead of opposing it. Then we would jerk the wire downwards. A current will flow to jerk the wire down even more, which in turn will cause a greater current, which will make the wire move down even more, which will produce an even greater current, which will cause the wire to move down even more, until there is a never-ending occurrence.
An electric generator works by electromagnetic induction. It uses magnetism to make electricity. The power source spins a coil between the poles of a magnet or electromagnet. As it cuts through the lines of force, an electric current flows through the coil. The large generators and power stations are powered by steam turbines or water turbines. The electricity reaches our homes through a network of power lines. Initially, the current travels at a very high voltage because much less energy is lost in transmission than if the voltage were low. Transformers then step down the voltage to different levels for use in industry and in the home. Alternating current, or AC power, is created from a hydroelectric generator and comes out of a wall power socket. Direct current, or DC power, is electricity from a battery.